All right, so today we're going to kind of go back. So we talked about electrical force, and then from there we figured out electrical potential energy, and then we kind of discussed a little bit about how the electrical potential energy on a charge in an electric field really indicates, how much work can be done on that charge as well. We took a little bit of a break away from those concepts to look at Ohm's law. Current equals voltage over resistance. One of the other ways that we see that, and then we also did some variations of that. So for instance, if I clicked on, sorry, not click on, if I wanted to solve for R, I can know that resistance is equal to V over I, or if I wanted to solve for V, and this is the way a lot of places will see it, so V will be equal to current times resistance. So these are really the three different permutations, if you will, of Ohm's law. This is one I like the best. This is one you're typically going to see more. So kind of building off of, force to energy. Back when we were doing the more two-dimensional Newtonian stuff, the next topic we talked about was energy. How much work is done per second, how much energy is transferred per second. And we have essentially electrical power as well. So the words, uh, the equation for electrical power is P equals current times voltage. Okay, so power is equal to current times voltage. Once again, current will be in amps, voltage is in volts, or sometimes you'll see voltage as the electromotive force. To me, they're just the same thing. This equation is still very basic, kind of power is still in watts. So this is specifically when we start to see like electrical power of a light bulb, for instance. It's in watts. Um, Bigger things, the electricity, the power, the electrical power going through your home is typically going to be in kilowatt hours, I should say. Um, oh yeah. So anyway, um, this electrical power equation though, over here I've identified that I can be rewritten as V over R. V can be rewritten as I times R. So based on, if I have my circuit diagram here, positive end, negative end, okay, this is going to be a basic circuit. All right, so I've got voltage here. I always like to say that I've got current running through the whole thing, and the resistance item up top. Depending upon which of these three things I know, like if I know resistance and voltage, if I don't know current, and let's say I don't want to go through the very, very simple process of figuring out current, using just V and R, I can actually just use the power equation. So let's say, for instance, let's say R resistance is equal to 15 ohms and the voltage is, oh, let's go 9 volts. Okay. Well, right now, and I don't know current. Okay. So with this circuit, I really don't know how to solve for power, but I don't have I. According to Ohm's law here, current is equal to voltage over resistance, okay? So that means I can plug all of this in for I. Like that's just basic algebra substitution, right? So now I can rewrite my power equation as V over R times V, or a better way to talk about that might be V squared over R, all right? So then I would take V squared, so I've got 9 squared, 81, power is equal to 9 squared over 15, 81 over 15. I'm not going to go through all that work to calculate out. You guys can do that. My big thing is just kind of go through the different permutations for power here. But it's pretty basic, okay? Done with that example. Now let's say that I've got a new circuit. We should probably work on those. Let's say in this case, I have a current of 0.3 amps, and I have a resistance of, oh, let's say, well, let's just go 1 ohm. Okay. Now I want to know what's the power of this circuit. Okay, and I don't know voltage in this case. So let's go back to P equals current times voltage, but I don't know voltage. Well, from Ohm's law, I know that voltage is equal to current times resistance. I have current, I have resistance, so let's go ahead. So voltage is equal to current times resistance. So now in this case, I can substitute that in for voltage. So now I've got power is equal to I times IR. I've got I times I here, so there's probably a better way to write that. I times I is I squared times resistance. So really, I had 3 permutations of Ohm's law. I'm really working with 3. Oh, so let's go over here. All right, so in this case, the power would be equal to, so I squared, so I've got 0.3 squared times resistance we said was 1 ohm. Break this down quick, 0.09 times 1 is 0.09 watts. All right, so big takeaway from this video, like I said, I'm not, that one I could do in my head. I think I did it right. Anyway, coming back here, the big takeaway is for the electrical power equations, we have 3 of them. The basic one, power is equal to current times voltage. Amps times volts, pretty straightforward. The second one we have is power is equal to V squared, voltage squared over resistance. And the third one you're going to be working with is current squared times resistance. These 3 are the ones you're going to look at. So for any simple circuit, you can go through. If you know current and voltage, you can solve for power. If you know voltage and resistance, you can solve for power. Once again, current, resistance. Essentially, these 3 make it so like you're not going through the extra step of solving for whatever variable you're missing. It's just you just identify which you have and go from there. Very basic. Math is pretty easy. So good luck.